All right, let's see if we can finish this off. So triangle ABC, we got angle C is 90, which is huge. That means we can use Pythagorean theorem if we want. Probably going to have to use some trig though. Angle B is 48. And the side adjacent to angle B is 2. Now think about this. This has to be my hypotenuse. So that means this must be what they're talking about, saying this is 2. They're saying find C. Well, C is always opposite angle C, which means they're saying find the hypotenuse. Now here's how you have to think. So, ka, toa. This is my adjacent side. This is my hypotenuse. Which of these three trig functions only uses adjacent and hypotenuse? Cosine. So that tells me I have to go cosine of 48 degrees equals adjacent over my hypotenuse. Now, whenever the thing you're trying to find is down in the denominator, it makes the algebra a little bit harder, but just don't panic. So I take my calculator. Once again, make sure you're on degree mode. And I'm going to find cosine of 48, which is 0.669. So we'll just call that 0.67. So 0.67 equals 2 over C. Now what in the world do you do if that darn variable is down in the denominator? Well, you got to get rid of it. And there's only one way to do it. Multiply by C. And you got to multiply this by C. And I know this is messy, but 0.67C equals 2. Now I have to divide by 0.67, divide by 0.67. So 2 divided by 0.67, enter 2.98. If you wrote a 3 in there, I'd be just fine with that. But if someone wrote 2.98, that's fine as well. And there you go. By the way, should the hypotenuse be a little bit bigger than this side? Yeah, it should be. It's always the biggest side. All right, next problem. It says find sine where theta in standard position, which is just drawing your attention, terminal side, those two things are just saying standard position just means start here. We already know that. Terminal side means it ends at negative 8.6. Don't be thrown by all that fancy language. So negative 8, negative 6 is right here. There's the point where the spinner stops. Well, if you remember, we have a 3, 4, 5 family. If we doubled all that, we'd have a 6, 8, 10. So that means our spinner is 10. Remember, our spinner can never be negative. Here's our reference angle right here. Always can't be this one. It's never this one, never the 90. It's always the angle sandwiched between the x-axis and the spinner. So it's saying find sine. Well, sine is opposite over hypotenuse, which in this case would be negative 6 over 10. And don't forget to reduce. That's just part of math. All right, now number 16 is getting more of like a puzzle. This is saying find sine if tangent is negative 12/5 and secant, this is a fancy way of saying, is positive. Now think about this. We have our little trick, all students take Calc, which teaches us all things are positive in the first. Sine is positive in the second. Tangent's positive in the third. Cosine's positive in the fourth. But secant is the reciprocal of cosine. So if secant is positive, then cosine has to be positive. So we go to this, we say, okay, where can cosine be positive? Here and here. Not here, not here. So that's part of the clue. This is a huge clue, and I always want my students to start here. Then I go to this one. This little clue right here is massively important because it's saying tangent is negative, because we got to figure out which quadrant of these two we're stuck in. Well, if tangent's negative, it can't be in this quadrant because all things are positive. So now I know where to draw my drawing. And also, that negative has to go with one or the other. So if we think about this for a second, tangent is opposite over adjacent. So to get our drawing a little bit accurate, you know, the opposite side needs to be quite large. So I'm going to make it like this, and I'm going to put the negative with the 12 because that's my down, and that's my opposite. My adjacent is 5. And hopefully you remember from geometry, 5, 12, 13. And this is my reference angle because it's sandwiched between the spinner and the x-axis. So what is sine? Well, that's opposite over hypotenuse. So that'd be negative 12 over 13. Let me pause this a sec. Last two. Angle A is 90. That's what that says. Angle B is 32, so I'll just put it up here because it looks 32 to me. Side A is 15.1. Find the approximate length of side B. So if this is angle B, this has to be side B. So what I'm going to do is I'm going to use this as my reference angle, which makes this my opposite side, this my hypotenuse. Now again, back up to here. SOHCAHTOA. Which trig function uses opposite and hypotenuse? Sine. So I'm going to go sine of my reference angle, 32, equals opposite over hypotenuse. And this time, the thing I'm looking for is not in the denominator, it's in the numerator. So I got to find sine of 32 degrees. Make sure you're in degree mode. 0.53 we'll call it. 0.53 equals b over 15.1. So I'm going to multiply by 15.1. They cancel. I'm going to multiply this by 15.1. I can just go like this, times 15.1. And I get straight up, almost straight up, 8. Okay? So there we go. 8. This one is going to require a little work. Identify the period and amplitude and graph one period of the function y equals 4 cosine x over 2. And so now we're going to take a look, and what I want you to do is remember what y equals cosine of x looks like. Now I'm going to extend this. Now I'm not going to waste. And so there, I labeled the drawing, so I don't have to waste your time. Cosine, we got to know what that looks like. It looks like this. Now I'm just going to lightly draw it in here, like that. That's our normal cosine curve. Now we've got to make the adjustments one at a time. So the amplitude is going to go from 1, because that's what this is, a 1, to 4. So 2, 3, 4. And then see that negative 1? It's going to go down to 2, 3, 4, down here. And this negative 1 goes to negative 4. And the zeros just stay the same. So that would go 1, 2, 3, 4. Forgot where it was already. It's going to go like this. And like this. Now I'm not done yet, because this says there's an invisible 1 there, which is telling me b equals 1/2. And so I need to use the formula. Period is 2 pi all over b, which is 1/2. So we'd flip it and multiply, so we'd get 4 pi. So this is pi to negative pi, which is 2 pi. So we got to extend the period. We got to double it. So this would go out to 2 pi. This would go out to negative 2 pi. So our period is 4 pi, and it just stretches it out. And then this point would go to here. This point would go to here. And then my final graph would be like so. And so what is our amplitude? That's 4. What's our period? That's 4 pi. And you got to label it because they asked you to. And that's it, guys.